Hi dear students, welcome to Gravity Coaching Center Tirupati. Today we will discuss current electricity of class 10 NCERT exercise questions. In that, number 1, a piece of wire of resistance R. What is it? Means we have a wire whose resistance is R, whose resistance is R. We have a piece of wire whose resistance is R, and this piece of wire is cut into equal parts. It's cut into equal parts. Suppose how many equal parts? 5 equal parts. 1, 2, 3, 4, 5 equal parts. We have cut it into 5 equal parts. We know that resistance R is equals to rho L by A, and here we have got a same kind of material throughout, so resistivity will remain same, and area of cross section also we have not changed anything. So this will also not change, this will also will not change. Only thing will change is the length. Here the length is changing, so the resistance gets changed of the new cut pieces. This 5 equal parts we have cut, right? That resistances will change. Since all of them are of equal length, they all will have equal resistance. Suppose that resistance to be small r. Okay. Now see, it's interesting to see that this wire actually in the beginning, see, it was joined how? End to end. This was how it was joined end to end, means it was in series. So when it was in series, its resistance how much? Equivalent resistance of this total wire was R. Now this cut equal 5 parts we have cut, right? Now this, what we have done is we have joined them in parallel combination. We have joined them in parallel combination. See this way. So like this we have joined, and what is each one's resistance is how much? Smaller, right? Now they are in parallel. Before they were in series, now they are in parallel. We have to remember one thing: in series, the equivalent resistance is R1 plus R2 plus R3 plus so on plus Rn. Here, interestingly, all the resistances are same in series. So if all the resistances are same, suppose R1 equal to R2 equal to R3 and so on equal to Rn, then we can write this one like R1 R, all these are equal to, suppose they are equal to R. Now R plus R plus R plus so on plus R. How many terms are there? Here I have taken generally n terms. How many terms I have taken? N terms. So if we have got 2 here, R plus R, 2R I will get. If I have got 3 resistors, R plus R plus R, 3R I will get. If I have got n resistors, then I will have what? N R. Here N R I will have, right? Since here I have taken small r, so here Rs I can write that as Rs equal to small n R into R. This is the equivalent resistance in series. So Rs means what? Here initially it was, Rs is nothing but R, it was the resistance of the wire, and it is equals to N into R. Let us suppose this as equation 1. The next thing, now the resistors are connected in parallel. So what I will do is, in parallel, you know that the resistors, how it will be? It is 1 by Rp is equals to 1 by R1 plus 1 by R2 plus so on plus 1 by Rn. And here also we have got what? Equal resistances. So what I will do? 1 by R plus 1 by R plus so on plus 1 by R. How many terms? N terms. Okay. Suppose if you have got 2 terms, then 2 by r, 3 terms 3 by r, 4 terms 4 by r, n terms n by r. This is 1 by rp. So if you reciprocate this, what will happen? If you reciprocate this, rp by 1 is equals to r by n. So this is 2, isn't it or not? So you can just take this one is also, okay. So this I will take this one, r equal to nr, and 1 by rp is equals to n by r. This one I will take it as 2. Multiply 1 and 2. Multiply 1 and 2. Multiply 1 and 2. See here, what is the one? R. What is the second one? Into 1 by rp. Rp means what here? Rp means in parallel combination it is called what? R dash. Okay. Here I can write this as what? 1 by r dash is equals to n by r. So into 1 by r dash, which is equals to how much? This is r is nr, and this one how much? N by r. 1 by r is how much? N by r. So r gets cancelled. Here r gets cancelled, right? R gets cancelled. N into n becomes n square. Here r into 1, r by r dash. So r by r dash is equals to what? N square. So we have got a general term when we have n number of resistors. But here how many resistors we have? 5 resistors. So put n equal to 5. If you put n equal to 5, what will happen? R by r dash is equals to 5 square. That is equals to how much? 25. That is equal to how much? 25. So our answer is option D. I hope you understood. Let us see. Let us try to understand. See here, in series, the resistors, equivalent resistance, how much? R1 plus R2 plus R3, so on Rn. And since all the resistors are equal, Rs is equals to R plus R plus R plus, we are replacing with R. Since there are n terms, what we will do? It will be nr. The similar way, the equivalent resistance in parallel is equals to 1 by R1 plus 1 by R2 plus 1 by R3, so on 1 by Rn. So since all the resistances are same, we will replace R1, R2, R3, everything with smaller. Okay. Now that will be equal to what? This will be equal to R by N. Actually, this will be equal to 1 by Rp will be equal to N by R. If you reciprocate, you will get what? Rp R by N. This is how you will get. So what we want? Rs by Rp. That is equal to Rs is how much? Nr. And Rp is how much? R by N. So this R cancels, N by N. This N will come up, N into N, N square. Rs is series combination, is nothing but R. In the parallel it is R dash. So R by R dash is how much? N square. It is how much? N square. So what we will do? N is equal to, put N equal to 5. You get R by R dash is equals to how much? 5 square. That is equal to 5 5 is a 25. Our answer is how much? 25. This is the first question. Understood? Let us go to the second question. Which of the following terms does not represent electrical power in a circuit? So what we know is power is equals to what? VI. From Ohm's law, V equal to what? IR. So instead of V, what I can put? IR into I. I into I is I square R. Okay. Now P equal to VI. Instead of I, what I can put? V by R. V into V, V square by R. So totally we have got I square R formula, we have got VI formula, We have got V square by R. We have got all these formulas we have got. Okay, this one is not there. Here we don't have this one. Understood? So it's a small correction. It should be V square by R. Okay, so here this is irrelevant here. So this is the, which of the following does not represent electrical power means IR square does not represent, IR square does not represent what? Does not represent electrical power. Doesn't represent electrical power. Okay. Next question. Let us see. An electric bulb is rated 220 volt and 100 watt. Okay. It is rated how much? 220 volt and 100 watt. So, rated voltage how much? 220 volt. And rated power how much? Rated power how much? 100 watt. Next question. This is third question. So, you see here means when I buy any object, any bulb or any electrical appliances, there will be this rated voltage and rated power. It will be written on the box. So, that is what is given here. And the same bulb is used for operating at 110 volt. So, operating voltage how much? 110 volt, and the power